I welcome you all to this webinar on the topic Ultimate Guide to Career in AI with Prabhakaran Chandran. Let me tell you a few things about Prabhakaran. Prabhakaran is a data scientist at Captain Fish, specializing in data science, machine learning, and data engineering in fisheries and marine resource management. His role involves collaboration with cross-functional teams, utilizing tools like Python, PyTorch, TensorFlow, Dectron 2, and AWS MLOps to develop data models. With a bachelor's in instrumental and control engineering, he started his career in MU Sigma, working on data-driven projects across various domains. Prabhakaran is passionate about harnessing AI and data for social and environmental goods and actively contributes to the AI guild community. Now I'll let Prabhakaran to take it on from here.
Let's get started with the session. So it will be like an ultimate career map for data and AI related careers. So we'll emphasize more on AI, which is talk of the town. And then what is AI? So mostly like we say AI is artificial intelligence that's gonna sweep away our jobs and all those things. But when it comes to AI for enterprises or AI for the industries, like any industry, you can take it like a retail, banking sector, or CPG, packed foods, or anything like automotive industry or aerospace or anything. So we can actually, when it comes to industries, the problem statements or the aspirations can be brought in four major chunks, which is content, commerce, customer, and operations. So content is nothing but the problems which are related to the content or the whatever we show to the clients, like what should be my recommendation, or what can be an effective marketing technique would be, or who are my customers, like when should I launch some product, or when should I target them. So those kind of customer or content generic things are available. The meanwhile, things like the sales related or commerce related, which is the trade related problems are also available. The questions like, can I increase the price now? Or what will be the sales next year? Or is it worth investing in a certain portfolio or not? So those kind of questions are actually involving huge money, investment, commerce, sales, trade. For that, we would require an enterprise level intelligence or data science use cases or AI applications. Right? The same way we can do it for operations. So there are four major pillars of problem spaces, and you can start with any of them. If you just start with one question, like how industries use AI to determine pricing, or how industries use AI to determine production planning, or machine learning to determine production planning. So this one question, because the entire session is going to be triggering you with multiple questions and pushing you to find answers and the paths to that. Okay, so for like to solve these kind of problems, we actually delve into three major like equilibrium of data, product, and engineering. Because it's not always just building models or coming up with some codes, right? It has to be in a consumable format. It has to be easily understandable format. So that's why teams are concentrating more on like three different chunks. One is concentrating on data, ensuring that we have enough data and we have quality data for further analysis or further problem solving. For that, we deploy teams of data engineers, data analysts, data scientists. So in that case itself, you can find three different career options like data engineering, data analysis, data science. You can get into any one of them in terms of like finding a path towards a career in AI and the AI related stuff. And there is a team of engineers who can scale that, who can, whatever solution that we build, whatever code or whatever models that we build, that has to be scaled, that has to be put for the entire world to be used, entire world to consume, because we use ChatGPT these days, we use a lot of AI-based APIs these days. All of them are not just data science products, they are actually the engineering marvel where we are able to like handle that much amount of people at the same time. We are able to like scale our models to millions of people at a time, right? So engineering is also one of the perspectives. So if you are good at data structures, algorithms, you are good at system thinking, if you are good at like programming and writing very good scalable systems, then your career path should be towards engineering side. And if you are not good at coding or a mathematical thing, but if you are good at understanding the business needs, you are good at problem solving, then the career path that you need to target is product side. How can I utilize AI? How can I harness the power of data and machine learning to solve a specific industrial problem or social problem? So there you can concentrate on it. So this equilibrium is important for any company to sustain in an AI or deep tech adoption. Because if you are not good at engineering, our product will suck. Or if you are not good at product side, we will not be able to get more adoption, like user experience, or bring more aspirations. So that we will not be able to do it. So that's why the equilibrium is important. And the data and AI careers are abundance in this data side and engineering side. We'll deep dive into what are those things, like what kind of insights that we would be able to get, or what kind of opportunities are available. So what I have done is I have divided the different opportunities into the life cycle of a data science or AI problem. So whenever an AI problem comes into the company, let's say, or if any company or any business wants to solve an existing problem with the help of AI, that actually deals with four major things. One is problem definition, because without understanding the problem, we cannot do anything, because we cannot just fly in the assumptions or just going behind our aspirations. We need to have a strong evidences that whether the problem is worth to be solved or not, or whether the problem has very huge potential in terms of returns, whether it has a many like very good opportunity in terms of dollar making, right? Like getting revenue or getting more user base, or solving increasing the user experience. So those kind of quality parameter has to be studied. So for that, we have the foundational analysis, where we will be utilizing the data, the existing data, in terms of understand what is the problem and what is the nature of that particular problem, what actually causes the problem. Let's see how these AI teams look like. So most of the time, there will be a business or product teams who are functioning into like in terms of analyzing, like who can do this problem definition and fundamental analysis, whether the problems can be solved or what to solve, or what kind of business impact it can make. So that kind of ask will come from problems assessment will be taken care by business with product teams. And based on that, there can be two scenarios. One, in scenario one, in both the scenarios, we would need a data and analytics engineering team in order to bring in the initial analysis and also the very good data for the further solution building. Because in machine learning, we say garbage in, garbage out. In order to ensure that we build very good model, we should ensure that we have very good quality of data. And for any industries with users of thousands of users, lakhs of users, the size of data is so huge. So we need to concentrate on data engineering and analytics engineering in terms of processing them, storing them, and doing the further analysis. In the first step analysis. And then in scenario one, data scientists will do a tailor-made and reliable models, because it is not just dot fitting things, or it is not just using some scikit-learn or some random Python packages. It is more or less coming up with a very good model which can solve the business problem. It is not just one line of code or two lines of code. It will always in an iterative one, right? Once those models are finalized, that will be given to the ML engineering team. They will actually bring the model to the production, right? And then we can actually delve into like this thing. The software engineers team, they can actually complete the end-to-end products, so that we can push to the clients or the users. That is one thing. The other one, there are certain problems which are very niche. The problems can be solved easily, or the problems are repetitive, or the problems are kind of common across the industries. For that, we can still use very basic models available in open source. No need to put much effort in terms of modeling, but more efforts to be put in terms of scaling the models for high number of users, and putting your team to expand it to the like high scalable system. So that is what the scenario 2. So here you can see that the machine learning engineers are taking more advantage these days. So that is true because almost after ChatGPT's launch, we could see the shift in data science hiring, and also the team setup, where teams are more concerned about building products, consumable products, not spending much time in terms of research and running behind multiple solution use cases, right? Whenever, if you take any industries or any teams, it is actually the interconnectedness between science, engineering, and data. You can get into any of them. You can get into data engineering side, or you can get into science or engineering side. Where engineering, you can concentrate more on like how can I bring, or how can I perform the machine learning activities at scale? Because you always should have one thought: the data that we handle in the industries is not so less. It is always in GBs and TBs. To do that, to efficiently perform whatever we wanted to do with the computation, we need to follow a strong engineering design. And whenever we build models or whenever we deploy something, we need to follow certain concepts like going with the serverless mechanism. So serverless actually concept available in cloud computing, where you won't own any consistent infrastructure. Whenever it is needed, it will be developed. So likewise, whatever the new words that you are hearing today, if you are interested or if you are excited by that particular word, it is always suggested that like you note it down and do your research. Start from that particular thing, right? As we say, big data has high velocity, high variability, and high variety. So variety of data sets are available. It's not only the tabular data or just a numerical data. It is always, it can be like audio, or it can be an image, or it can be a video, or a text related information. So that's why it is like we have like bunch of opportunities. Let's say if you are interested in audio processing, or if you are interested in image recognition or computer vision or image generation, right? So you can start yourself with, okay, I have an image data set. How should I start building some solution further? Like, how can I do object detection over there? How can I do classification over there? Start with the question. Start with an aspiration. Okay, I got inspired with, or I got interested in causal inference, or I got interested in statistical learning. Okay, where can I start? What is the fundamental for it? Okay, is it statistics, or is it mathematics, or is it simple Python programming? So you should ask multiple questions, whatever new words or whatever new aspirations that is actually making you more confident or excited about the AI careers, right? If you want to get into this data or analytics engineering, simple, learn Python, SQL, Excel sheets in order to perform data analysis, data manipulations. And you should have very strong analytical reasoning skills. Should be having a thought process of why it is happening, what it is happening. So those kind of question driven or problem definition based analysis would help you. Current or modern AI jobs, it can be divided into two major things. One is discriminative AI and generative AI. If somebody is not aware of discriminative AI or generative AI, discriminative, or the word discrimination, means distinguishing or differentiate two things. For example, you have 10 customers. You want to distinguish them with the help of whether the customer will purchase your product or not, or whether the customer will come to your city or come to your thing or not. So those kind of loyalty related or those kind of customer behavior related stuffs cannot be generated, because generative AI is nothing but generative, right? Generative is nothing but a creative one. What is the expectation outside? Because right now I said that, okay, this is the opportunity, this is what companies are doing or anything. But the expectation is what? the companies would have, like, it will be in 4 different scenarios, but it will not be always equal for every company. Some companies would give more preference to science, some companies would give more preference to business. It depends on the company, but commonly what is the require fundamental expectations, and the minimum expectation is nothing but, if you want to be a data scientist or AI engineer or ML engineer, if you are good at fundamentals of science, or which is statistics and calculus, that's good. And if you're good at reasoning behind algorithms, why are we using this particular algorithm? When should I use the particular algorithm? Let's say for a specific business or a specific use case, certain algorithms won't work, right? In that case, we should be able to have the reasoning knowledge behind assessing in each and every algorithms. So this is the current state of dreamers, doers, and dictators. Dictators are nothing but those who decide where the next set of researchers should go, what kind of product that we need to invest in. It's more or less like people, those who are in decision making, are compelling others to follow certain things, right? So as a beginner, most of the time we are not interested in foundations. We just, okay, some model is built, some 1 or 2 line code is enough. I can put myself as a data scientist. That was the reason, right? Or we just like do cliche project. When we, as a beginner, we keep on repeating the same type of project. For example, we keep on do a specific Titanic dataset project, or any other niche or like redundant dataset project. That's why it is always suggested that like we learn fundamentals. We are trying out multiple approaches. We are evaluating them. We are writing a blog. We contribute to the open source, because that will actually push you far away, from the problem statements to nearby the problem statements are the academia, because academia are kind of doing a lot of research especially in the language models and NLP, and they have huge potential for it. That's why we are actually pushing ourselves. This is the requirement. We should not be following a very naive or very immature way of learning. We should always follow a mature way of learning. That is what I wanted to pursue in this one. How to get started? Because there are section of people, those are interested in a specific use cases. For example, I see people interested in code. Some people interested in are very good at mathematical thing. They're very good at calculus, are very good at representing or interpreting algebra or probability stuff. Some folks are very good at problem solving in business, because in money making world, in the world which always targets the returns, it's not just technology or just mathematics or just math. It is always the mix of everything. So we have room for everything. We have opportunities across all of them. So what I would suggest is, if you are good at technology, learn any of the programming language, any of the low level or middle level thing, like Go also you can learn, Go, Scala, or simply you can learn Java or Python. But learning Python is very good, very promising for your career also, because most of the data science or AI things are being written in Python thing, right? So you can learn Python, try to utilize a lot of open source APIs so that you will build things from end to end. So what you are doing here is you are just stitching things. Everything is available here and there, but with the help of code, you are stitching it. Then you can do modifying certain things. You can fine tune your model so that you are going to the next step. Once you are able to do this, learning to fine tune a model for your custom problem statements by playing with certain parameters, then you will be able to clearly find your path in terms of machine learning engineering, in terms of building very good systems. So these are all the trigger points where to start. If you ask me, like, you just Google this, or just go ahead and talk with ChatGPT. Okay, how can I learn coding and build an API with ChatGPT? So it will give you the 1 week or 2 weeks learning thing. So always I would say, like approach in a man-machine way, where utilize the human intelligence based on the experience.
Ultimate guide to a career in AI was truly enlightening. In just 1 hour, you have provided invaluable insights that can shape their future in their path for AI. Thank you for sharing your expertise and passion with us. And once again, thank you, Prabhakar, for taking time out of your busy schedule.
Yeah, thanks a lot, Ayan, and all the best for every participants. And make use of the available resources in terms of learning and practicing and acquiring the opportunities. Thanks a lot.